Hi everyone. We'll start with the sensor network scenario in this session. So it gives a brief idea what are the scenarios available with respect to the wireless sensor network. So everyone knows that you will be having a wireless sensor network where we'll be deploying the sensors to monitor the environmental conditions. And depending upon the applications, we'll decide whether you have more number of the sinks or you require more number of the sources. We have an options like we'll have multiple sources. For example, if I'm going for monitoring temperature of a field, I can deploy more number of the sensors to collect the temperature of the field and send to one single sink, which is your monitoring, which might be your monitoring unit or it might be a cluster head or so on. Similarly, you can have a multiple sinks also. So one single source will be there, and from there you can transmit to multiple things. It is like when you go for any intelligent building, the details of that building will be available to all the persons who were coming and viewing that building by means of the sending to their handheld devices. So that we call it as a multiple things. So always we'll have a complex information flow that will reach the right sync even though you have multiple things available. So these are the three types of the mobilities that you can observe with respect to the wireless sensor network. So first one, we have node mobility. We can see all the three in details in the further slides. So the first one represents the node mobility. It means that whichever be the source of information, so that node itself will be keep moving. And the second one is your sync mobility. The point which collects the informations from the field will start moving by one from one place to the another place. So that we call it as a sync mobility. And the last one is the event mobility. What is event in the sense? Suppose if I am deploying the fire sensor or the smoke sensor, if there is an outbreak of the fire, by the time only the sensor will be stimulated and it will raise an alarm or it will show some indications. So the sensor which can sense the data and transmit the signal based on the occurrence of the event, we call it as an event driven wireless sensor network. If that event is going to be moving from one place to the another place, we call it as an event mobility. So all the three types will comes under the mobility of your wireless sensor network, because in a network we have only two options basically. So one will be the source node, which is going to collect the data from the field. Another one is going to be the sync node, which will be collecting all the data from all the source nodes in the network or else multiple sources in the network. And one more option, we have a special case that we call it as a relay node. In case if your source and the sync node is not able to connect directly, by the time the relay node which lies in between, which is also a source node, will help the primary source node to transmit the data to the sync node. So this is example. This is the description of the node mobility, and this is an example. So node here, it is the source of information which is about to move from one place to the another place. Example, very good example for the node mobility is the livestock surveillance. Suppose if I am going to monitor the habitat, if I am habitat of an animal, by the time I can place a sensor in the animal, the body of the animal, and will try to focus towards what is the habitat of that particular animal from the morning till evening. So here we cannot expect the animal to stay in one single place, so it will be keep roaming from one point to the another point. So this is the very good example for the node mobility. So whichever be the source here it is an animal with a sensor node will be keep roaming, so we'll collect the data from it. So here we cannot expect a static network, because the animal will be keep moving, so the topology of the network will be keep varying. So we'll say there will be network reorganization all the time, and we have to maintain a energy trade-off as the animal is going to move from one place to the another place. So there will be a energy utilization all the time, because that has to be managed, and so that we can collect the data sufficiently without any loss. And the next one is the sync mobility. So in the sync mobility, what we'll do is, so here you can see you'll be having this is, and we consider this as an intelligent building. The person will be having a PDA in his hand. So it's an handheld device. So he is the person who is requesting the information from the intelligent building. So here you can see the intelligent building will serve as one single source, and like this person you can have any number of the persons walking around the corridor of the intelligent building to know about the nature of the building or the characteristics of the building or the history of the building. So like that there you'll be having a many sources, many things from one single source. So here the mobile requester, he is the person who is requesting to interact with the wireless sensor network in order to collect the information. So sequential requests can be sent because one person here and another person is here and another person is here. All these persons will be trying to communicate with a single source node in order to retrieve the data which is locally available or in the nearby vicinity of that particular person. So this is the handling of the mobile syncs. So here whatever we have seen the previous diagram. So that is this is the flow of that mobile sync. So if the mobile sync continuously moves throughout the sensor network, the challenges intensifies because the configuration of the network will be keep changing because the person is going to move and if the person is moving, so initially if it is going to be a one single defined topology that will be keep changing, or else if the particular person you have is going to put off the PDA and is has stopped communication with the source node, again the topology changes. So all these things will be a very big challenge for the data to be transferred from source node to the sync node. So this is the flow of the informations, how it transferred from that of the sync node to the source node and vice versa. So initially the request will be sent by the sync node to the nearby nodes. Mobile sync queries nearby nodes. So or else you will be having a source node from where you are about to get the information. So the initial request will be sent. So once the initial request is sent to know about the building history, so here the or the informations will be available in the source node. So that will be transmitted to the sync node, which is requested for the informations. So requester relocates and while data is being retrieved. So once you assume that person is in the position x1, y1 and has requested for the data and later on he has moved to the new position of x2, y2, but still he has to get the same information what he has requested for. So that is we call it as a dynamic routing. Even though the position changes, the sync remains the same and the source remains the same. So it has to be carried out. And the third category of the mobility is event mobility, as we have seen already. So event is the occurrence of anything which has to be monitored by the sensor is the event. It might be outbreak of the fire or it might be the occurrence of the rain. Like this, the only at that time the sensor will start sensing, it will be transmitting the data. So in applications, you can see that event detection or object tracking will be depending upon the person, the event which is going to move. Here, what is event is you can see the circular lines where you have your sensors is being deployed in the circumference of the circular lines. So the sensor has to monitor if any elephant comes into the fence or the fenced region, by the time it has to monitor. So this is the event occurrence or the entrance or entry of the elephant is the occurrence of the event here. So this has to be monitored. So if the event is here moving of an elephant. So here you can see continuous coverage. Sufficient number of sensors must actively monitor the mobile events at all the time. So this has to be taken care of. And here the dynamic activity zones has to be designed based upon the sensors. The sensors will wake up around the object to observe it, and once the elephant moves away from the vicinity of the sensor, it gets into the sleep mode. So based on the event mobility, we have a model called Frisbee model. So we all know what is Frisbee. So if the disk of the Frisbee is going to be thrown, so it will be moving, it will be ejected from that of the source and it will gradually move towards the longer distance and get settled in the destination. The same way here you can see tracking of elephant is the event to be considered. So the active zones is the sensors will be observing the event in a highly active manner when the elephant is going to enter into the zone of monitoring. So once the elephant leaves the zone, automatically all the nodes which is sensing earlier will get into the sleep state, revert to low power sleep states. So information, so some sleeping nodes may wake up temporarily to relay the node in order from the active zone to the remote sinks. So that will help the active sources to transmit the data to that of the sync node. So in case if the distance between the source and the sync are too far. So this is will be here again as the event is mobile in nature. So the energy utilization has to be taken care of. So these are the algorithms for wake up the wavefronts. So you can see event directions. So initial sensing of the mobile object by a few nodes. So occurrence of the event has to be monitored always, and these are all related with that of the event mobility. So wake up coordination. So whichever be the sensor node is awake and it is keep monitoring the event occurrence, it has to predict the movement and prepare for the activations. All the active nodes which is sensing the data, that is the event occurrence, has to process the data about the event which has occurred, and it has to transmit to that of the cluster head or to the sync node. So what is cluster head is the node which is represents the all the informations collected from all the sensors in the node. We call it as the cluster head. So the information has to be routed to the sync in a proper manner. Either it can reach the sync node in a single hop manner, or else it can reach the sync node in a multi-hop path. So once the data has been transmitted to that of the sync node, it will get into the sleep transition. The reason for getting into the sleep transition as soon as the event occurrence has been monitored, to in order to maintain the energy level of the sensor, it will get into the sleep transitions. So these are the key takeaways based upon the dynamic construction of wireless sensor network. So here, first point is adaptability is key. So the network has to reconfigure itself uh, to accommodate the changes that has taken place. So as we have discussed already, so there is a possibility of the mobility with respect to the source, with respect to the sync, or with respect to the event. So whatever it occurs, the data transmission in the network should not get affected. So the elimination or addition of the nodes in the network should not affect the data transmission. So that we call it as adaptability of the network is the key point with respect to that of designing a wireless sensor network. The next point is the energy efficiency. As the sensors keep monitoring the environment, the battery of the sensor has to be taken care of. So optimization in the battery management has to be taken care of. So this will be the research focused area of a wireless sensor network. The third point will be the advanced algorithms. So intelligent protocols has to be taken into consideration for tracking the data for as well as to routing the data to that of the sync node. So and to coordinate all the nodes present in the network. For these purposes, you require an algorithms which will help us to establish a effective wireless sensor network. So the last point is application specific. So here we have different mobilities and we have different way of topologies can be arranged for monitoring the environment. So design choices depends upon the specific use cases that you are going to apply and the mobility type. So for example, if I'm going for monitoring of an agricultural field, in that case, we'll deploy the sensor physically and it is and the sensors need not be mobile in nature. Whereas if I'm going for monitoring of a habitat monitoring of an animal, definitely the sensor will be mobile in nature. The source of information is mobile in nature, and the deployment of the sensor will be specific to one single animal. So this will all comes under the application specific. So depending upon the applications where we want to monitor the data, we design the network accordingly. And with this, we conclude the network scenario. Hope this will give an idea. So, what is the different type of mobility we have with respect to the wireless sensor network, and how it can be implemented by choosing for accordingly for the applications. Thank you.